Hello and welcome to episode 84 of eCHO. I'm very excited for this session. This is our discussion with Deutsche Telekom. We're going to be talking all about kind of cloud native technologies and telco, the problems and the solutions therein. So I would like to welcome both Chris and Vuk to the room. Well, everybody.
Hi.
Fantastic. If you'd like to introduce yourselves to the audience, let everybody know who you are and what it is that you're working on.
Yeah, I'll just.
Thank you, Dan.
Okay.
So I'll just start. Sorry, Christopher. I'm Vuk. I'm a squad lead of what's officially called Kubernetes Engine Squad, or our platform team, and at the same time product owner for this platform known as the Schiff, or as we are recently rebranding it to TCAS for the internationalization purposes.
Yeah, I'm Chris, and I'm on that particular squad that Vuk just has mentioned. I am focusing mostly there on the networking stack of Kubernetes. That we have to build and make to work with the cloud native telco requirements that we have, because telco is funny. You will learn that today. And been part of the journey now for roughly 2 years.
Fantastic. Yeah, as you mentioned, telco has its own set of unique requirements and challenges, which I think not necessarily everybody is aware of. So I am super excited to kind of learn from you, learn what it is that you're doing, the problems that you're having, and the solutions that you're kind of coming up with for those. But before we delve into that, just going to kick things off with upcoming events like we normally do on eCHO. I think kind of pertinent to this conversation, Cloud Native Telco Day, as part of the pre-KubeCon events. I'm super excited for that. I believe one or both of you are probably going to be at the Cloud Native Telco Day at KubeCon. Excellent.
I'll only be there, Christopher, not this time.
Okay.
Sadly not, but yeah.
Okay. Additionally, on the same day will be sandboxed. Again, super excited, looking forward to that. And then the rest of the week is largely going to be filled with the cons sessions and things like that. So it's going to be a very exciting week in a couple of weeks' time. Some kind of recent news that just want to make people aware of. There's a lot of discussion at the moment. So Kubernetes k.gr.io, so the Google Container Registry, they're now deprecating that for Kubernetes images. And you need to, if you're using that, direct now to registry.k.io. There's a lot of people kind of making a lot of noise about that, because at some point or other, people are going to start hitting issues with being able to get their images in the future. Happy birthday, Docker. So Docker is 10 years old. I saw it get in the times, but the video of Solomon Hykes on stage at PyCon talking about the future of Linux containers, where he showed off the Docker engine written in Python at the time for the first time. So that's excellent. The Docker Hub confusion. So there was a new blog post announced today on the Docker blog, but effectively the team's accounts are being retired, and people are going to have to move to user accounts. But that's confused a lot of people. Look, Docker have kind of come back with a new blog post helping people understand what that actually kind of all means. So a couple of bits of information for you there. Yeah, awesome. There's a couple of comments. So a comment from Liz here. Very excited, con coming up. Yeah, hoping to see a lot of you there. I'm super excited for that. Sean sending a birthday cake for Docker as well. So excellent. Excellent, cool. So that's kind of some of the recent news and upcoming events. let's kind of kick things off. So I'm going to hand it over to you both. But if you'd like to talk about, kind of what it is that you're doing, what it is that Deutsche Telekom does, and kind of what it is that you're focusing on.
Okay, I think it makes sense to give a little bit of introduction and the background for the audience, where we are coming from, what we are actually doing, a bit more context so that we can discuss the networking things in a more comprehensive way. So first of all, about Deutsche Telekom, that's most valuable European brand, not Deutsche Telekom itself, but Magenta T. So forget about BMW, Mercedes, Louis Vuitton. The Magenta T is the hottest brand and most valuable brand from Europe, at least for this year officially. It was announced. We are an international communication service provider, telecom and system integration group, proper, I would say, international corporation with over 100 billion euros market cap, 100 billion euros annual revenue, and the core business is providing the communication services like connectivity, fixed mobile communication, and multimedia services, covering entire spectrum of different types of customers and use cases and so on. So for people who are not knowing us, it's let's say from the other side of Atlantic, on the west side of Atlantic, it's our biggest segment, T-Mobile, or how we like to call them, T-Mobile US, because for all people from that side who are listening to us, there is T-Mobile in Poland, there is T-Mobile in Netherlands, there's T-Mobile in Czech, so it's not only a thing in US. So that's the biggest segment. We have also the Europe segment, which is a group of the opcos or operators in the Central Eastern, also partially in the Western Europe. We have a big system integration arm called T-Systems, active globally. And last but not least, we have a segment Germany, where it's our home market, where we are belonging to. We are part of that segment, and more particular, the division called Deutsche Telekom Technik, which is our technology unit, so to say. So this is where we are coming from, and where we do our challenging work.
Excellent. Cool. So in terms of, kind of the technologies infrastructure, kind of for those that have only really kind of been in the cloud space, can you kind of allude to what the typical infrastructure looks like, kind of what speeds and feeds you're kind of dealing with here?
No, yeah. That's actually where to start from on that one. Probably we should we should touch upon the term telco for all those who are not from the industry. So telco,
100%.
we use it very, very often to refer to telco grade, to telco services, telco technologies, and so on. But the term telco is essentially the umbrella term for set of architectures, designs, technologies, solutions that are needed and used to provide our communication services. And in a simple terms, we are calling it internally, colloquially, a technology, but that's not your normal IT. That's actually very far away of your normal IT. It's also very far away of the backend for your iOS or the Android app. It is, how to say, it's obscure and occult place. It's a forest of applications, which we even do not call them applications. We call them network functions. And these network functions are connected, having a funny names, abbreviated names, and then connected in the service chains. And these service chains are actually for the purpose of delivering our services. So maybe I would show, to illustrate that, I would like to pull out one slide to show, actually, need to put that a bit
Wow, that is a complicated diagram.
That's essentially, I hope you can see it better. This is what I was talking about. I was referring to. We have here two examples of two services. One is an IP voice service, and another is more recent, more let's say hot, trendy 5G standalone service. And you see these boxes in between. So essentially, if you imagine historically, these boxes were really hardware boxes, the devices, and each of these lines that is in between them was actual physical connectivity, the cable and the physical interface. So at some point in time, when we as an industry, plus I have to say, these are only two examples. Now take this over the generations like 2G, 3G, 4G, 5G, fixed and mobile, TV services, streaming services, business services. So you end up with that forest, which I'm talking about. So when the IP started being a thing, then we started moving all of this to the, let's say, from the proprietary specific telco stacks into more IP on the networking side. But hey, there was this VRF thing, and we said, yoo-hoo, let's use it. Let's make all of these domains in their own VRF, and these dotted lines make them actually part of the very private network. So you end up, or we ended up, and we are currently in a situation that each of these network functions, or sometimes entire domain, is with the many legs into many VRFs. So we have examples with one of the containers, let's say, in the new world, need to be in a 6, 7, 8 VRFs at the same time in order to provide the function. So that's essentially what we are bringing now into Kubernetes. That's that's the situation we are actually currently dealing with, how to bring it to the cloud native. This brings
these
set
diagrams.
of challenges.
These diagrams are pretty impressive. I think a lot of people don't really. They get their phones and they do things, and packs just magically make their way to their mobile devices, and like under the covers is just almost a spider web of all these different kind of systems that are kind of doing the magic of getting packets from one place to another. It's pretty impressive.
Yeah, the purpose of all of these things, this is why I said it's not your normal IT. The purpose of almost all of these things is to either handle the packets on a user plane level, or handle the sessions and control data to make sure that every subscriber, every user has exactly what they want to, that the quality is assured, that the handovers in between mobile base stations. So it's a without exaggeration, a complex system.
And you mentioned network functions. So originally, these network functions managed by proprietary devices. I guess there was these like a box that a company would ship you to plug in, and then evolved into virtual network functions. And now today we are at container network functions. Is that the correct evolution?
So you use the term container network function. We do not like that term particularly.
Okay.
But the C is still in place. So we like to refer, or we hope actually, that they are evolving into so-called cloud native network functions, CNFs. But in our, let's say, branch of industry, there is always this confusion. The naming is difficult, so we call CNF, and then some people go away and say containerized network function, and other people go and say no, it's cloud native network function. So we are more in this cloud native camp,
right? Okay,
to be honest.
Or we want to be.
We want to be, correct.
Fantastic. So the evolution there of kind of these proprietary devices, and now we're moving cloud native and Kubernetes. So you've shown that diagram of what things used to look like. Kind of what's the migration path? How does that happen? How does that look, as it were?
Yeah, so we are talking, let's say, colloquially about cloud native transformation in telco, and this is a big term, which in a nutshell covers this transition from today's situation when we have either virtualized network functions or we have even more of let's say more traditional network functions, which are the silos with its own hardware, software, all based in the meantime, most of that based on x86 architectures and on certain form of virtualization, but still confined in the silo, delivered in a couple of racks, and that was that. So we are now working as a company. We are only one part of it, providing the infrastructure for that, on transitioning those into the cloud. One of the questions was how, what's the right approach for that, and there is a lot of discussion and stream in the industry. Is it a public cloud solution? Is something that we need to do differently than previously? So we decided for a way that is based on a bare metal Kubernetes. So we went into direction that is counterintuitive, I would say, for many, even today. We get the questions from the people, but how could that be efficient, or how could that be effective? That's not the thing that we should do. And indeed, depending from which angle you look at, it could be. So if you are coming, and by the way, we did that because we had a lot of experience from the virtualization effort, which started around about time when the Docker appeared in the world, so 10, 11 years ago. So we saw how difficult it is to run these type of functions in the shared environments, because they have and many times need to fine-tune some things even on the hardware level, and even in a contradictory way. So one function would require something that would make the other function having a problems. We talk here about very specific, let's say, hardware access, like SRIOV things. We talk about telco protocols, SCTP, SS7 signaling protocols over IP. So these things are were really difficult in a shared environment. And if you come from the virtualization perspective, where you consider, I built the hardware, the infrastructure with the big machines, as big as it could be, and then cut them into virtual machines, then you could say bare metal Kubernetes with such machines would make no sense. But we went completely different path. So we decided we go with the small, let's say, compute nodes. We go with even for a master service, even smaller compute nodes. We have a hardware that is 4 CPUs without multi-threading for these things, and so on. And around that time when we started a couple of years ago, the first CPUs with a single NUMA node started popping up, which was also a big problem for virtualized environment. How do you make sure that this inter-process communication for some very high performance and latency sensitive operations is not going via 5 processors back and forth and so on. So this is what we chosen. We also went into direction to, because this is a network at the end. So you need for every change to wire things in, but we also saw the pains of centralized SDN controllers. So we decided, Christopher will probably talk about that a bit more, to shift the intelligence from the center of the data center into the Kubernetes and Kubernetes nodes. So now, we ended up supporting this transformation from the infrastructure perspective with the hundreds and soon thousands of the bare metal nodes packed in the Kubernetes clusters and managed in a certain way. But that's not the subject of today's talk. I think we should go soon to the networking.
bare metal Kubernetes clusters normally people start sweating when that kind of topic comes up. But to keep kind of focused on the networking side of things, there's a question here. Do you see data path network functions becoming truly cloud native? Things like native scaling, flawless upgrades, and proper CI/CD pipelines.
Well, we are getting there, I think. There are some initiatives in the industry that hopefully will work, because as of today, as some know, we have most of the data path network functions requiring SIOV, so you're bypassing basically everything you would get from a CNI in your Kubernetes cluster, because you're from those for those who do not know, you basically slice your NIC into virtual parts. You have some control over them. Depends on the NIC vendor. There are also smart NICs, but doesn't matter right now. The thing is, it's not really cloud native. You don't have the CNI in there. You don't have any real control, and there are initiatives to get, for example, AFXDP with eBPF as kind of the replacement for SIOV to make it a lot easier to integrate with, of course, a bit of performance hit. Also, maybe some discussions. There were some talks from, I think, Red Hat at FOSCON regarding some CDP, I think, container data plane, also cloud native data plane, which also is in the same space, to get basically rid of SIOV, to make it to make the network functions run in a really cloud native and containerized way, and not like you get your VM that was previously your data network function and put it into a container, because that's not what we want. From a scaling point of view, I mean, as long as we still have kind of the usual design of a network function, they already, like for years, integrated into your network equipment quite well, I would say. For example, you already had your network functions that are handling data path traffic, talking to your routers, for example, by BGP, announcing your networks and so on. We are carrying that over also to the cloud native space, and that makes them also kind of scaling. But of course, you have to ensure that the control plane above it, which controls then the data plane or data path, knows about those scaling stuff. And I think that that's kind of already there. And maybe also covering the CI/CD part, because it's also interesting, but not really on the network side. We've chosen in the beginning to really focus on GitOps. We want to also kind of say to our internal customers, hey, and also to our suppliers, we are a GitOps-based platform. So if you want to deploy something on top of the platform, please use GitOps. We use Flux in the case here. And please make sure that, for example, during rolling upgrades, or even that's really a nice thing to have. Even if you would delete the cluster, please make sure that when the cluster comes back up and everything is bootstrapped by GitOps, that your whole 5G standalone core in that case comes up. I mean, we are not there yet, I would say. We are getting there. But it's a really interesting journey, also together with the suppliers to get there. And
that seems pretty amazing. That, like, kind of doing a few commits and all of a sudden a full a 5G platform almost pretty much spends up its life. That's the panacea of automation at this point, I think, by the sounds of it.
It's actually on all these aspects differentiated, and we have, as you've seen on the picture, it's not one box, but it's many boxes connected, and all these boxes or network functions are delivered and developed by different teams, groups, companies, vendors, and so on. So we see the spectrum there. We see the examples where it's very much ahead, and we have also cases where just a fully automated GitOps-based deployment of the complex things like 5G core comes up in 10, 15 or so minutes, and it's completely deterministic, predictable, so there is no question where to connect, what to configure. So I would say on the CI/CD part, that would be probably first, let's say, cloud native maturity milestone that will be reached. On the scalability there, depending if it's, for example, we run also 4G, and when you talk about components like MME, they are developed previously and are now mostly like 5-7 years ago, and they are mostly now maintained and imported into from virtual machine into container. And these things do not really have this flexibility and light weightedness of cloud native. So that's probably going to be a second part that requires rewriting of applications. And the networking part will probably come as everybody's in telco relying on SRIOV, will probably come later, because it would really require all of them to rewrite their data plane and data user plane handling stack, which is time consuming. So it's a journey, and they are, as always, the pioneers, the front runners, they are laggards. So that's the situation about it.
It sounds like you're very kind of almost in terms of adopting a lot of the newer technologies to do these things. I suppose a quick question: when you're at a CNF, are you given the data path? Do you know what it should be ingesting and what it should be kind of egressing, so that you know how to slot it into the platform? What does that look like?
For example, in the case of 5G here, which we are mostly talking about, we know, for example, there is one data plane function, which is the UBF, which is formally called user plane function, because it's handling user plane and user traffic. And that one we know, okay, it needs a leg basically to be configured from, for example, from the SMF, session management function. And then we also, of course, know, okay, it needs 2 legs, one of them in the radio side and one of them on the internet data network side. And we kind of know what it is, what it needs to talk to, but because we heavily split those up, and because of the requirements that they have, and a UPF usually is implemented in DPDK or a VPP. You also, of course, have the requirement of SRIOV. So you need to find a way to make SRIOV in your network on a automated bare metal platform is scalable, because in the end, with SRIOV and without, for example, something like SmartNICs or DPUs, you end up basically doing VLANs again to the hosts, with one VLAN being the radio side and the other VLAN being your internet side. And of course, getting there and maybe actually moving away from it to make use of a lot more, for example, encapsulation technology there, either requires moving to something like IFXDP or other possibilities, or to build servers with DPUs or SmartNICs, which then take care of the encapsulation, which of course is still not mature, I think, from a implementation perspective, and also of course still a bit on the cost heavy side. I mean, if you would put a SmartNIC DPU in every server, it of course increases the cost of them.
Okay, yeah. For those that are probably not really also, I mean, SmartNICs are pretty a newish addition to servers. Can you kind of quickly give a bit of an overview?
Well, I wouldn't actually call them newish, to be honest. I think we are, however, right now seeing more or less a push into more the enterprise, also telco stack, because if you look at all your public cloud providers, they have been using SmartNICs for years now.
Okay.
Azure has FPGA-based implementations, as far as I'm aware. AWS, Google both have their own and sometimes also sourced implementations of SmartNICs for quite some time now, where they actually offload quite a lot of data plane from their VM hosts to that card. But coming to the point, what a SmartNIC does is basically you're getting another computer in your computer or another server in your server, which then controls the network card itself, and you can do all kinds of fancy firewalling directly on your server card. You can get, for example, firewalling and encapsulation for especially those SIOV interfaces that the SIOV interfaces are a slice of the network card, so you don't have that much control from the host, and from a SmartNIC you have.
Okay.
Also, you can do quite a lot of stuff with them, and quite a lot of interesting work is being done there. For example, with NVIDIA's Bluefield, the whole host-based HBN host-based networking stack that they have. That's
Cool. Well,
quite some nice work.
Yeah, thank you very much for giving everybody an update into SmartNICs. We've got a couple of questions that have come in, so I'll just quickly get this question up from Tuxakos. Do you allow on your platform attaching multiple network interfaces to a single pod? In case yes, and how are you handling any potential security risks coming from such an implementation?
Well, we all know there is Multus.
Yeah, I was about to say.
I don't want to. Okay. There is also from the same group, from this network plumbing working group. There is also this multi-network policy project, because like usually you would have network policies, but your network policies are being enforced by the CNI, be it Cilium, be it whatever. And on secondary interfaces, you usually don't use Cilium, you don't use anything else. You probably go to MAC VLAN or IP VLAN. And with that, you don't get any network policies that you can enforce from the CNI. And with that, of course, you leave your pods quite open to the world. But with this network policy, multi-network policy project actually from them, and they have the implementation that actually writes IP tables rules, it's possible to secure them a bit more. The only thing I dislike about that project is specifically they write the network policies or the IP tables rules into the network namespace of the pod itself, and because they can't put them outside of the pod, because that would require bridge filtering from IP tables, and because of that, particularly, of course, depending on the security rights that the pod have, they could, in some cases, get rid of them. But you usually, and that should be best practice, have on both sides of your traffic either a network policy, or if we need to connect to traditional zones, of course, you end up with a firewall on the other side, and having your traffic crossing either two network policies or two firewalls, or one network policy and one firewall, reduces the risk, of course. But yes, we are requiring to have multiple network interfaces on a pod to answer the first question.
Mm-hmm. The project that you mentioned, is that an extension of Multus, or is this something entirely new that's in development at the moment?
It's from the same group. It basically relies on Multus being used.
Okay.
Because you also reference the network attachment definitions in the network policies. And yeah, this is the way they kind of reference them. And yeah, it's also now supporting IPv6 for some months, I know, as far as I'm aware. So it's usable to get some security on those Multus interfaces. What I would love to have, of course, at some point, with CNI, I think 2.0, there are some discussions around, or with future CNI generations, there are some discussions around multiple network interfaces from one CNI without the need for Multus. I know that, for example, Google is driving it. I know Cilium as well, from what I've heard.
Mm-hmm.
Yeah, that will be an interesting future because it allows us to really have the CNI control on both of them and not need to rely on Multus, McVLAN, and all those additions that are feeling like porting VM stuff to Kubernetes world.
Yeah,
because
absolutely.
This is definitely a retrofitting of Kubernetes for something that was not meant to be there. And on that security topic, I have to say, because we went into really making a platform with very little compromises, cloud native. And this entailed also at some point building the service areas or building the availability zones, which actually do not consist or do not contain the firewall in the traditional sense. And you can imagine what kind of discussion was there in between, let's say, people who are in a normal traditional telco world. You would have everything completely isolated behind the firewalls, behind the CG NAT gateways, different layers of isolation. And you come into the distributed computing world of Kubernetes, where you say, hey, the protection mechanisms are network policies. Okay, then how do I apply network policy on secondary interfaces? For some time, there was really no good solution, but luckily there is this multi-network policy kind of clone of normal network policies for the secondary interfaces. And this is what we live with, but that's not the most optimal state in which we would like to end on the long term.
Absolutely. Well, thank you very much for that question. Please keep the questions coming in. So I believe you're going to delve into a little bit more detail in terms of what the networking architecture actually like and how all the pieces fit together. All right.
Yes, so I'll actually try to go back to screen sharing, which I don't.
All right.
Should be working. Going back to the slides that I want to have. So I think everyone kind of knows a traditional Kubernetes cluster. I don't need to really explain how a Kubernetes cluster itself connects to your network in a traditional sense. You might have, for example, BGP running there with your CNI to your whatever top of rack router, whatever you have. But we've chosen a bit of a different way because we are in the more or less problematic situation that we have those like a lot of networks that we need to attach to. Previously, in kind of the old design, old world, you would have a central firewall or would have central routers, which have quite a lot of legs into all the different virtual routing and forwarding instances, like those VRFs that I've mentioned. And Then on the other side, spit out VLANs for everything that you would end up needing. One for, I don't know, one for the signaling on the radio side, one for signaling to your customer mobile database, whatever you have. And as we wanted to actually remove central components, Vuk already mentioned that we did not want to really use SDN controllers. Also, we wanted to remove central firewalls because we really wanted to get into, okay, network policies are the way how things should be handled. And the host should mostly decide where the traffic should go and not something on the router. Because if you would want to do that at a router level, of course, you can do that, but you would be in the need to configure your router, like where traffic should go where. For example, some people know about the route leaking part, which is very time consuming to sometimes debug. And this is an issue that we've seen, and also it makes the routers really having a complicated config in the end, which no longer can be maintained easily. So we moved things to the host. So what we do is we are making our hosts actually part of something called an IP or EVPN fabric that we use. An IP or EVPN fabric basically is built around BGP and the EVPN extension of BGP. And we use it quite extensively or quite a lot with the EVPN type 5. So my dream, and this is really why we do that, is to have everything routed to the host, nothing layer 2, just plain routing, because it makes things a lot more easier than having layer 2 networks, which are sometimes very behaving weirdly. You have broadcast art, whatever. In really the best case, you have everything routed to your pod. Not only your primary interface is routed, like in most CNIs, but everything else is as well, like your secondary interfaces. And this is what we are not getting with Multus right now, but might be getting with in the future with the CNI stuff. So how does that look like? You see this picture here. So basically we have from a network connectivity on the host perspective, everything is like we have each VRF would be theoretically available at a host. And we have each VRF that we can directly tap into on the host by by also configuring it there. And that makes it really easy to have the host like the central configuration point, and also reduces kind of the blast radius because you just have that host or that cluster with the connections. We have, for example, like the two networks here. Each of them are in an EVPN type 5 routed. Everything is host routes or prefix routes. And we also have the pod routes, like the Kubernetes cluster itself, also in additional in another VNI and route target, as it's called in BGP. And also the pod IPs are kind of announced into that EVPN because why not use it for everything then? And that allows us to really on the host consume it. For example, we have kind of the default VRF that we stick to not have to move Kubernetes into a different VRF. And then we have like different other VRFs that we can connect to. For example, a management VRF that is used for management of the nodes and for management of the Kubernetes cluster. It pulls images from there and so on. But we also can have like different VRFs. Like one example would be the radio access site control plane, or the signaling stuff for handover to 4G for a different 4G core or whatever. You have like all those VRFs that you can directly consume from the host and dynamically configure by, and that's a nice thing that we built with this with a project called Network Operator by typing in Kubernetes resources or by applying Kubernetes resources, and this network operator then configures on the host the routing agent. We use FRR, free range routing in that case, and also netlink, which is needed for that kind of stuff. And yeah,
Can you make the diagram a little
makes
bit bigger,
things-
just so?
I try to, yeah, that one I have it
There
here.
we go.
Yeah. We have some base configuration that it consumes, but it also consumes those resources from the Kubernetes cluster, those VRF route configurations, and then puts them into the FRR config and dynamically configures the host. And of course, having it as a custom resource in Kubernetes makes it GitOpsable. So we have it in GitOps as well. So it gets applied from Git. So the network host config is completely coming from Git. And we don't need to change the network that much, or the underlying switching fabric that much, to get a basic cluster running. We have that for VRFs. We have that for actually also now layer 2 networks that are solely MAC-VLAN or IP-VLAN. We can also directly configure them on the host, making the host actually the Anycast gateway. What we don't have, of course, is the same for SIOV. So SIOV is kind of the case where we still need to configure VLANs to the servers right now. Because there isn't really a good solution to do that without going to DPUs or SmartNICs or off-the-shelf components which configure, for example, the ConnectX-5 Mellanox card, because you could already say we are using ConnectX-5 quite a lot, and mainly you could say that for example, this card that we're already using is a SmartNIC because it already supports encapsulation, decapsulation, as long as you write the rules to it. But there is no component as of now which does that other than Open vSwitch. And maybe going into that direction, we did not actually want to use Open vSwitch at all, because Open vSwitch is also kind of this OpenStack project that comes from VMs, is also using layer 2 quite a lot and putting that onto pods where we actually in a really future dream case want to have only routed networks to them feels completely wrong. And this is why we actually decided to not use Open vSwitch, for example, at all.
Okay. I love this. This is like YAML-defined routing, basically. It's
yes, exactly.
Fantastic. We've got a quick question that's popped in. So some functions doing IPsec encapsulation. How is that handled in containers? Is some eBPF used to set up the IPsec tunnels as a function and moving that away from the app? So, I mean, I suppose the first question is, are the functions that you're doing IPsec encapsulation?
We haven't seen one yet, to be honest. There wasn't yet a requirement from anyone to have this IPsec encapsulation. I think there was one briefly, but I'm not sure how they actually would handle that. One would need to look into it, how they do it, either by using the kernel part, IPsec part, or doing it completely different. Good question.
What is that with IPsec gateways actually that we use in order to connect to the endpoints which require that? So it's on a data center level, something on the border gateway, or not on the border gateway, but that's a function that we also have mandatorily in place in order to support the integration with such functions.
Okay. There's a number of acronyms here that I certainly don't understand. Let's give it as an example.
Yes, well, the PCSDF, as far as I'm aware, even in voice over LTE does not terminate IPsec itself. There is this, and throwing out acronyms again, ePDG, which does the IPsec termination for this thing called not VoLTE, but voice over Wi-Fi. In non-3GPPX, whatever. Don't want to go into that too much, but yeah. Okay, it does. Interesting.
Okay.
Yeah, but not heated yet.
I'm getting a little bit lost here with everything that's going on. Excellent. Okay. Cool. So in terms of where you're at today, in terms of the platform, we kind of covered that it's a very complex thing running, kind of these various kind of telco mini platforms that you have inside that do very different things, from 5G to IP to the VoIP and things like that. Where are you at now? I mean, you've seen the thing, kind of it stands up to a certain degree. Where are you at, and where are you kind of hoping to get to?
So at the moment, actually, we are in the beginning of this what we call cloud native transformation. We have a 5G SA standalone leading the pack. That's actually one of the newer standards that was defined and standardized around notions of containers and even cloud native notions. So that's the pretty obvious one. More legacy functions like these IMS related functions that we see in the chat with abbreviations, yes, they are following. We will still need to see how that all fits together with Kubernetes and cloud native, but our main focus now is really supporting this massive transformation. I would say we have several programs running, several streams, as I said, and scaling up the capacity, scaling up the operations, scaling up the onboarding efforts, and being able to host those functions. Just to give a ballpark figure, so we are expecting in a course of next 2-3 years to end up aggregated capacity with aggregated capacity of 5, 6, 7,000 bare metal hosts distributed across number of locations to host all of these things. Just to give a order of magnitude, so that's actually what's ahead of us. Of course, continuous evolution of the stack, still addressing the points that are suboptimal from the current perspective, like this. Looking forward to the native multi interfaces in Kubernetes at some point. Looking forward also to replacements of SRIOV. It's exciting at the end, seeing how different players are addressing it. How it's also business that is having a lot of legacy, and there is a lot of cash cow milking type of approaches. So the industry is not moving really eagerly into new areas because there was invest previously made. So it's exciting to see how actually this will turn out, and step by step are we going to do it better than in a virtualization case.
Yeah, it really does feel to a certain degree as though networking is kind of especially in the cloud native space, there's a lot of work to do. We're starting to see a lot of people move more complex applications onto Kubernetes clusters that need to interact with existing systems, existing platforms need to get their data from kind of one environment to another, and being able to build kind of those bridges between your native forms and kind of existing infrastructure there has been a large gap there, and Kubernetes has been designed to a certain degree to really kind of run in kind of cloud environments, and a lot of the functionality does exist out of the box in order to do those sorts of integrations. So there's kind of almost reverse engineering that is kind of happening to a certain degree. And to your point earlier, like we don't really want to reinvent the VM fixes that we kind of had to implement again and again. So it is a very interesting space at the moment. Fantastic. We're kind of coming up to the top of the hour. So what's kind of the future? What are you really kind of hoping to kind of get to?
Well, the future, hopefully a lot more quality pushes towards really cloud native network functions. Getting rid of SIOV at some point. Some CNIs, of course, supporting more telco features like Cilium already does with some SCTP ingress, some basic work, for example, some other work on the egress side of Cilium, as you're on the call, then like CubeWeb is now doing, for example. Yeah, that would be nice. And this multi-network requirements cap that was mentioned, the enhancement proposal from Kubernetes, which I've earlier mislabeled as CNI 2.0 or the work, but that's what I've mentioned earlier. That would be really nice to have as an extension of Kubernetes directly from a ZIG networking point of view, because I think that would make it a lot more mainstream, and it would also improve on the collaboration on it than what we have currently in the network policy, in the network plumbing working group, because that's making it part of Kubernetes is, I think, the right step, because they would kind of acknowledge that Kubernetes is used for this kind of workloads in the future.
Yeah, absolutely.
Maybe I briefly step in, not or partially about the future, because I spotted the question in the chat about if we are using Cilium eBPF at the moment. The answer on that is no, but it's being considered. And let's see what the future brings. But we are definitely looking forward to that.
I certainly think for the multi-network requirements and kind of getting away from IP tables as much as possible, being able to having multi-network interfaces, having eBPF being able to attach to both of those and having a single set of rules, it should, in theory, kind of simplify things and make, like, from a development perspective, at least in my head, it is a simplistic kind of path moving forward. Fantastic. Well, thank you very much both for joining. Thank you very much, everybody who's asked all of the questions that we've had today. I have certainly learned a lot of acronyms that are used in the telco space. It's fantastic to hear about, kind of the underpinnings, the architecture that kind of goes into these architectures. Also, I believe you mentioned, 5,000, 6,000 bare metal nodes. Is that correct in terms of the sizing? Big clusters. I like hearing about big Kubernetes clusters that people are actually running. So,
that's going to be a lot of small clusters.
Well,
does not or medium-sized clusters. As of today, we have clusters with the 50, 60, 70 bare metal nodes. Probably is not going to go in the open AI numbers, which they have these. They are, I think, test bed for the Kubernetes scaling. So they are going into 5,000-7,000 nodes per cluster. No, we are doing a multi-cluster distributed in a lot of cities and places, and in a sum, in aggregated sum, it results in many bare metal nodes.
Mm-hmm. And is that GitOps multi-cluster, or is that kind of how you're approaching it?
Yeah, correct.
Very cool. Okay, that's amazing. Cool. All right. Well, thank you ever so much. I look forward to finding out more all around kind of the cloud native telco space. As mentioned, this Cloud Native Telco Day, which is coming up a couple of weeks' time at KubeCon. So there's going to be a number of sessions around that and throughout KubeCon as well. So fantastic. Thank you ever so much again. And I look forward to seeing everybody on the next eCHO session in a few time. Thank you very much, everyone.
Thanks, Dan.
Thanks for having us.
No problem.